My name is Batrisyia Sofea Binti Rofidi. So today I will present about the concept of linear function in physics, which is constant velocity. So first thing first, in this presentation, I will explain the science concept and the relationship of linear function in the science concept, the experiment conducted, the model, the explanation, and the constant velocity. So let's look at the science concept for the linear functions in physics, which is constant velocity. So what is constant velocity? A constant velocity is a velocity that does not change. It means when the object is moved with constant velocity, that means the object has covers equal distance in equal time interval in a particular direction. So how to determine the constant velocity? So we have three steps to determine the constant velocity. So the first step is we need to do the experiment to investigate the motion of object with constant velocity. And the second step is we need to record the time taken for the object to move with certain displacement. And the third step is we need to plot the graph of displacements against time, and then we can calculate the value of the constant velocity. So next we go to the relationship of linear function in the science concept, which is the constant velocity. So what is the relationship between the linear function and the constant velocity? So we can get the constant velocity when the graph of displacements against time taken show us a straight line. So the diagram below is the example of the linear function graph. We can see the straight line and the y and x axis. So the straight line of the displacement against time taken, graph will show us a constant velocity. So let's we know more about the linear function and constant velocity. So the straight line from the graph is defined as a linear function, and the constant velocity also can be determined by calculating the gradient from the graph. So after that, I will explain on how to get the gradient from the graph. Okay, next we go to the experiment to get the data to plot the displacement against time graph. So the experiment I did was analyzing the motion of object with constant velocity. Let's look about the video of me conducting the experiment. So based on the experiment, we get the data. So after we get the data, so this is the tabulation of data from the experiment, and from the data we need to plot the graph displacements against time. So this is my displacement against time graph, which I have 4 points which fit in the best fit line, and 1 point defect from best fit line. So this is my y-axis. Y-axis is displacement in unit meter, and my x-axis is time taken in the unit of second. So next we go to the explanation from this graph. So the linear function graph have its own equations called linear equation, and the linear equation is obtained from the straight line of the graph. So let's we go to the linear equation of the straight line. So this is the equation of this is the general equation of linear function, which is y equal to mx plus c. So each of letter here represent by its own function. So y is represent y value, and m is represent as gradient, x is represent as x value, and c is represent as y intercept. So we know that y value and x value we can get from the data directly, but the letter of m and c we need to do some finding to get the value of m and c. So how to get the value of c, which is the y intercept? So before we go further, we must know the definition of C. C is the y-intercept, which is the point where a line crosses the y-axis of the graph. So we can see this. We can see these red dots here is the cross between the straight line, and the cross between the y-axis. So this point is called y-intercept. So next, we go to the how to get the value of m, which is the gradient of the graph. So the gradient of the graph can be obtained by calculating the slope of the graph. So what is slope? Slope is defined as the ratio of the vertical change between 2 points, the rise, to the horizontal change between the same 2 points, the run. So the line here, which is parallel to y-axis, is called as a rise, and line here, which is parallel to x-axis, is called as run. So this is the equation of gradient, which represented by the letter m, which is y2 minus y1 divided by x2 minus x1. So before we want to calculate the slope of the graph, we need to draw small triangle connecting the 2 points that lies on the best fit line. So this is the example of triangle here, and connected with the point 1, which is x1 and y1, and connected to the point 2, which is x2, y2. So next, we go to the linear equation of straight line based on my graph. So this is the equation of linear function I got from my graph, which is y equal to 0.87x minus 0.59. So y is a y value, 0.87 is the gradient, x is x value, and negative 0.59 is the represented by c, which is the y-intercept of my graph. So let's go to how I find the value of m. So just now I said we need to do a small triangle connecting 2 points that fits on the best fit line. So this is the point which where I choose point 1 as 1.83, 1.0, and point 2 is 0.91 and 0.20. So based on this equation, I substitute the value, and I got the gradient of my graph. The gradient of my graph is 0.87. So let's go to the finding of the c-intercept, which is I got is negative 0.59. So how I find this? So this C-intercept is the point where the straight lines cross the y-axis. So this is my point, which is negative 0.59 here, which is my straight line, best fit lines across the y-axis. So I got the y-intercept is negative 0.59. So after we got the M and C, we need to substitute each of this value into the general equation of linear function, which is the y equal to mx plus c. So this is my equation after I substitute all the value of M and C. So next we go to the how this constant velocity, how we want to get the constant velocity from the graph. So how do we know that the straight line of the displacements against time will produce the constant velocity? Just now I will just said that the constant velocity is we got from the straight line of the graph. So let's know about this thing. So the answer for this question is we need to compare the value of M, which is we need to compare the value of gradient. So how? So first thing first, we need to choose. We need to draw two triangles that include two different points. So for the first calculation, for the first M, I will choose this point, which is 1.83 and 1.00, and the second point is 0.91 and 0.20. So after I substitute the in the equation of gradient, which is M equal to y2 minus y1 divided by x2 minus x1, I will get this answer 0.87. So for the next value of M, I will also draw the triangle here, which I need to choose the point that lies on the best fit line, which is 1.37, 0.6, and 0.91, 0.2. So based on this calculation of gradient, based on this equation, I got also the 0.87. So we can see that the value of M here is the same. So we can conclude that the constant velocity of the velocity of the object is constant. So that's all from me. Thank you.